morning, everyone, and welcome to OpenCV Weekly Episode 95. I'm Phil Nelson, the co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you can call me Phil and I'll be your huckleberry. I'm coming to you live from beautiful downtown San Francisco, California, where everybody loves the acclaimed. And we have an awesome show for you today. We'll be learning a lot more about the Intel Developer Cloud, the super powerful platform we've done a few episodes about recently. We've got Meghna Rowe joining us once again for the second time to be telling us about the incredible power available to you through the container playground powered by Red Hat OpenShift. Welcome, Meghna.
Thank you so much, Phil. Thank you so much for the introduction, and thank you everybody for joining us from around the world today. I would like to start off with a brief introduction to myself. So I'm an AI technology evangelist working at Intel Corporation. Been here for a little more than 12 years now on the same role of technology evangelist, but I have moved from one technology to another, and I have been in the space of AI technology evangelism for the last 7 or 8 years. So today I would like to talk about the Intel Developer Cloud for the Edge, the container playground capability in particular. I was on the OpenCV show a few weeks ago. On that episode, I talked about the bare metal development, and we have since had another set of speakers from the Intel Developer Cloud for the Edge team who have brought in topics around how you can do your workload evaluation on the latest and greatest Intel hardware. But today, I will focus more on the cloud native development.
Before we get started, I'm going to remind you of a few things we do every single week here on OpenCV Weekly, the first of which is a giveaway to you in the audience. Later on in the episode, I will ask a trivia question based on the slides here, and then you will have the opportunity to answer that trivia question in Zoom and win a free copy of the Mastering AI Art Generation course currently on Kickstarter from OpenCV. You can go to Kickstarter and search OpenCV, or to go to opencv.org/Kickstarter to get to that campaign. There are just 5 days left to save big on our most affordable campaign ever, just $29, and you can be generating really cool AI art with your friends and family as a gift, just for funsies, whatever you want. Currently, $116,000 raised from 1,236 backers, just 5 days to go. Get in on it. You will not regret it. As a reminder, also, this show is sponsored by OpenCV.ai Consulting. Get consulting from the best luminaries like Dr. Stia Malik, Gary Bradsky, Anna Petrovicheva. Go to OpenCV.ai, fill out the form, say hey. Can't hurt to have a conversation. Geez, I'm really off today. We're just going to get started. Meghna, please take this show away from me.
Okay, perfect. So as I mentioned, I'm going to be talking about the container playground capability of the Intel Developer Cloud for the Edge. What we hope to cover today, I will give some introduction to what exactly the cloud native landscape looks like and what the differences are between developing applications as containers versus the traditional model of development. And we will also talk briefly about some of the primary characteristics of containers, what actually makes them the best fit for the cloud native environment, and what are some of the ecosystem enablement that is supporting container development. So that will be the first section. I don't hope to take too much of your time away just talking about the theory. The second part, I would like to jump right into the Intel Developer Cloud for the Edge. There, we will quickly recap on what the core capabilities of DevCloud are, and then we will go into some of the workflows, whether it is a low-code, no-code scenario or a pro-code scenario, bringing in your own containers, bringing in your own models, or bringing in your own source code and data. What are the options that exist for you to actually build containers out of any of those assets, and then ultimately actually test them on real-world Intel hardware. So that is going to be the focus of the presentation here today. So with that, let's quickly jump to what the traditional model of development is versus what the container world actually looks like. So if you focus on the image on the left, This is the traditional space where you have the hardware, you have the operating system sitting on top of it. Then you have a whole bunch of applications that are running on that stack. So it could be a database, it could be a Node.js application. But what essentially this is introducing as a complexity here is each of these applications have their own libraries. They have their own dependencies. And these dependencies could clash with one another. This problem gets even more compounded when you actually look at different versions of the dependencies that you all are trying to install on the same machine. And this could create a very strong dependency matrix that makes it extremely difficult to kind of isolate different components and make them modular enough to run in a cloud environment. So compared to this, when you look at the image on the right, this is a container system where you again have the hardware and the operating system, but you have a lightweight container engine on top of it. And as you can see from each of the individual buckets that you have sitting on top, now the applications are actually packaged more modularly with individual libraries and dependencies all going into those individual containers. And this actually makes it a really good application development methodology for you to ultimately take your application from development into a stage where you are able to build it, package it, ship it, deploy it, and have better manageability and better scalability. But what exactly are some of the key parameters that kind of assist the cloud native system? Okay, something happened. Give me
It's
just
all
one
right.
second.
Through the magic of editing, it'll be as though this never happened.
Yeah, absolutely. So, so here are three main pillars of containers, right? The first one is orchestration. What exactly does that mean? So this is a concept where something really as lightweight as a container can actually be moved around from one cluster to another. Let us imagine a scenario where you are deploying your application, it is running on a pod and it runs out of CPU cycles. You have the flexibility now to take that container and actually deploy it on another pod and take advantage of the hardware resources there. Something that can be done so effectively in a rule-based environment makes it extremely effective in edge deployment scenarios. And that is one of the primary pillars of containers. The second is the concept of microservices, because containers, they have existed for a while, right? So what is this concept of microservices? If we go back to our traditional environment that we talked about just a few minutes ago, when you have to deploy it, this is a very bulky setup. If something goes wrong in one aspect of that entire monolith, you are now left with having to either debug the entire application or even deploy the entire application to even cascade that small change that would affect the bug fix, right? But that is not a very effective model when you have large scale deployments. Microservices, on the other hand, is a concept that breaks this monolith into individual units. There are best practices that you could use to develop microservices. Traditionally, or one of the best practices is that you kind of use this one container, one app model and have functionality that is quite granular and expose clear APIs that can be used by other microservices to communicate. So essentially, this microservice concept is a whole lot of microservices, each doing individual granular functions that are communicating with one another, either through the messaging system, event-driven systems, data passing between different microservices. All of these capabilities really makes it extremely easy in a real world deployment scenario, where if something goes wrong, it's only that one container that you have to worry about. You don't have to bring the whole system down, right? So that is the second pillar of containers. And the third is packaging. So again, let's take a quick look at that journey. When you are in the application development phase, right? You are using a model, you're using a data set, you're training that particular model, and then you are packaging that model in some form. But that's usually just one component of your final solution. In real world deployments, it's a lot more complex than that. You could have multiple models that you're packaging as one solution. And in the realm of containers, there are a whole lot of graduated projects on the CNCF foundation, like the Helm charts and the Docker Compose, that essentially help you to package multiple containers into one solution and ultimately be able to deploy them. So these are the three primary pillars that are really driving the momentum for containers in the cloud native ecosystem today. So all of these cumulatively, when we compare how they benefit the container system versus the traditional way of application development, you can actually see that in terms of installation, the traditional model is a lot more time consuming. Whereas in containers, it is a quicker process, mainly because it is that much more modular. The dependencies, we have kind of isolated those. Packaging them becomes easy, mainly because there are standard ways of doing it. Taking a solution from development, staging production through to final deployment becomes a lot easier in the container ecosystem. It's also a lot more isolated, and scalability, because of all the aspects that we've seen on the top, becomes an easier proposition in the cloud native world as well. So here is just a quick example that I want to call everybody's attention to. On the left, we have a set of instructions, right? Let me open up the website. And as you can see here, what we are trying to do is install the OpenVINO runtime on Linux. And if we go through this entire web page, you will notice.
Not seeing the web page here, still seeing the presentation. I think you need to take it
Okay,
from
I think
full
I'm just
screen.
going to, yeah, I think I shared just the application. So let me quickly stop sharing and share the entire screen. That should make it easier for me to swap between windows.
All right.
Is this coming through?
Now we are seeing your like speaker notes here.
Really?
Yeah.
Okay.
I don't even know what this is from. Not a Windows guy. Yeah.
Okay. I actually lost the screen sharing ability.
Let's see here. um, no, you're still sharing, so I think you need to maybe unshare and then reshare again.
It's kind of what I'm doing. Screen sharing meeting. I just lost that window at the top.
Let me see if I can I'll force stop you here.
Sure.
And then let you see if I can let you again. Or, maybe I can. Here,
Oh.
let me see. Oh, you got it.
Okay. I think it's the cancel screen share.
Yeah, as a reminder, folks, we are taking questions from you in the audience. If you have any
Is this coming
questions,
through now?
it's looking good. Yeah, use the Zoom Q&A button at the bottom of the screen if you're in Zoom, or use the chat system wherever you're watching to ask your questions. We'll do our best to answer them. But
Okay.
now I'm seeing your speaker notes again. not seeing your. It's very odd. Like
Okay.
yeah.
We just tested this a short while ago and everything
Yeah.
looked okay, right?
A new screen to me.
Mm-hmm.
I need like some kind of technical difficulties image I can put up there. Let's see if I can gin one up real quick.
Let me just go into the non-screen share. Let me go back here. Try this. Is this coming through?
Yes.
Okay. I think the problem is with presentation mode. All right.
Sense.
So we lost a few minutes there. I apologize. So let's go back and take a quick look at what I was talking about. So if we kind of compare the monolithic model with the container way of doing things, right? As we can see in this particular page, you have a whole lot of system requirements, a whole bunch of installation instructions. So you have to go through these in strict sequence. Something goes wrong, you have to rinse and repeat. On the other hand, if we go back now to the container way of doing things, you essentially pull a container from a repository. In this case, you're pulling it from a repository like Docker Hub, and then you run the container. You have to, you kind of, um, uh, you don't have to worry about all of those installation issues that could come up if you were installing instruction by instruction. So that's just one of the advantages, right? So now let's take a look at the ecosystem that I was talking about. So in this scenario, those three pillars that we talked about earlier, they are very strong um, aspects of why containers are gaining a foothold in the cloud native space. But this is also a paradigm of application development that is backed by a very robust ecosystem. So if we look at the different components that I'm sharing on the deck today, you'll see that there are specific frameworks that support microservice development, like Spring Boot. This is a Java-based environment, or gRPC, that is the communication paradigm between the different containers, right? How do you build a container out of different components? You have Dockerfile and Docker Compose, Dockerfile essentially to build the containers. But again, you could have multiple containers coming together to form one solution. And that is where we have the graduated project like the Docker Compose and Helm. And it's not just those open source projects. You also have a whole lot of public and private registries like Amazon ECR or Docker Hub, Red Hat Quay.io, at the Azure Container Registry, where you can actually host your containers and then pull them on to an environment like the Container Playground to actually evaluate your containers on. And also, if you have IP that you don't really want to share, you could put them on a private registry and then use them for your own internal purposes. And these are all backed by industry consortia like CNCF, right? So this is essentially what the landscape in the cloud native realm kind of looks like. Now, let's take a quick look at how the Intel Developer Cloud for the Edge propels this container movement, right? We've talked about the Intel Developer Cloud for the Edge in a few past episodes, so I do not want to dwell too much on what we have already talked about. But just as a quick recap, there are multiple challenges that we have seen our customers and developers encounter when they are developing applications and solutions in the AI world, especially for the edge. One is actually the lack of access to a wide variety of edge hardware. And another is that hardware and software choice paralysis, not having to have the development environment completely set up. You don't have to go through that headache, right? And the manageability across the cloud to edge continuum. And that is kind of where the developer cloud for the edge comes into the picture. It gives you full stack reference implementations that you could leverage and build applications from. There are familiar IDEs that you can use SDKs and toolkits and libraries through and develop your applications and just test them on the underlying hardware without you having to worry about any of this. So we are not talking about what goes into the container. We are talking about an actual environment that is allowing you to test your applications and solutions. And there are different entry points here because we do understand that developers could be at different aspects of this journey, right? Some of you may be in the early stages of development where you are just trying to learn. Some of you may be farther along and you're trying to create an application. Some of you may be a bit further and you're trying to build a container out of it. Some of you have already built all of these resources and now you're trying to test, or you're using, or you are wanting to optimize your applications further using software. irrespective of what your entry point is, there is a capability for you to use the developer cloud for the edge. And this is actually common across the bare metal development and the container playground environment. But what we will focus on today is the container development environment, which is essentially a Kubernetes based environment. It supports your workflows of importing containers, evaluating through Helm charts, Docker Compose, quite a few of the things that I talked about. Essentially, the workflows that we have are, bring your own source, bring your own container, bring your own data or models, right? Irrespective of which one of those workflows you want to evaluate, the container playground offers capabilities for you to do that. And again, these are the container playground is actually built on top of Red Hat OpenShift platform. So by leveraging an industry standard popular capability and using that to provide with the robust security features and the configuration best practices that folks that are using Kubernetes are already used to using, makes it an even more compelling environment for you to take advantage of. And essentially, what is the container playground? It is a cloud desktop. Through a browser, you are able to access the container playground free of cost, and then you are able to bring in your workloads and do some of these evaluations, right? The bring your own container, bring your own source, bring your own data pathways that I was talking about. So at this point, I would like to switch gears and go into a real world demo of showing you how to actually do some of these things so you get a better understanding of what I just covered through slideware till now.
Brave live demo, everybody. Our favorite thing on this show.
Yeah. And I hope everything will work the way I want it to work. I've actually pre-populated some of these things. So, okay, here is the website, right? Devcloud.intel.com/edge. That is the homepage for all of you to try out later on. I have actually already created an account and logged in. But for folks that are first-time users, you will see two buttons. Where I have a request and extension, you will see an enroll and a sign-in option. So please request an account. It is important that you have a DevCloud account before you take advantage of either the bare metal capability or the container playground capability. So a quick run through of the website itself, right? So you have both the bare metal and container development. So for today's purposes, the get started environment here is what we will need. And let me actually pull this down a little bit. Disable annotations, hide video panel. We'll just escape to. Nope. Okay. Maybe I should just drag the window down. What am I supposed to do? Is it giving me a hard time? Let me try this and drag it a little. Oh my God, please. Okay, so here is the environment. And once we come into the container playground, you will see that in the My Library section, open the import resources, and you'll be able to see all of the different pathways that I talked about, right? Importing from a container, importing resources from a Docker file, importing your own source code through Git repositories, or you even have full stack reference implementations through the container playground marketplace, Helm charts, Docker Compose, all of these capabilities, right? So where did we access that from? Once you log in, you come into the My Library section and click on Import Resources. So in the interest of actually going through this entire environment from the easiest to the more complex, what I will do is go to the marketplace, show you that there are a whole lot of vertical specific samples that you could actually open up in an editor and take a look at the code. Further down, you will actually notice that there are reference implementations, right? So here I have intelligent traffic management as one reference implementation, a social distancing for retail as another reference implementation. What we will do here is take a look at what exactly this solution entails, right? There are multiple container images here, as you can see. There is a Grafana, there is a database, then there are two different solutions. Essentially, it is doing object detection using the deep learning streamer as the backend. There are two models, a pedestrian detector model, which uses MobileNet V2 as the backbone. And in terms of output, this particular solution is actually exposing two URLs that I will use, one to show the actual inference output itself, and the second to actually show you the analytics from the solution, right? So to be able to evaluate this on Intel hardware, like I said at the beginning, right, you have access to a whole variety of edge hardware that you can run your workloads on. You could click on the launch button from here or through the tile on the marketplace. When you click on launch, you will be taken to the hardware page where you can check out all the available hardware that you can test your workloads on, right? You have Xeon, you have Core i9, i7, i5, you name it. So let me just pick a random example and I'll launch the workload. So what you will see here is essentially your workload is being put in a queue and it is waiting for a particular edge node that you deployed your solution on to become available. And then you will see the status change from queue to waiting, deployed, and then running. So in the interest of time, I have already taken the other solution, which was the intelligent traffic management solution, and I've already run it on one of the Intel hardware here, right? So what this will do is it exposes two of the outputs here. If I open this up, you will notice that you have inference that is happening through the Grafana interface. And you will also notice that you can see analytics in another tab, right? I hope the video is still running to
Yep.
be able to show you the Grafana interface. Here you will actually see how many violations happened, things like that. Manage, I'll just pick one of the intersections, and as you can see here, what are the total number of vehicles detected, what are the total number of violations. You are able to see all of these. Essentially, these two are the URLs that the application is exposing, right? And this is happening through a secure route. So the application is not really I wonder what happened. Okay.
Quick
Something went
question
wrong.
from the audience here.
Yeah.
So far, everything you've shown us is free. Is that true?
Mm-hmm.
Wow.
Yes, all you need to do is create an account on
Mhm.
the developer cloud for the edge, as I mentioned. Your first time access will be given to you for 120 days, following which you can request for a renewal, and that renewal is free as well. So you can essentially renew as many times as you need.
Great.
So it is free.
Wow.
So we strongly encourage you to check it out. So the one other thing, after you saw what the Grafana dashboards look like, you could also take a look at overall system performance, right? This will also open up. This is still being finalized, so let's give it a little bit of time. So this is one capability, right? Here, all we did was we took an application that is a full stack reference implementation, and we actually ran that on a chosen Intel hardware. Let's look at a slightly more interesting use case where we will actually take an example. And because we are using smart retail, let me stick to that particular industry example. Again, here, if you want to take a look at the number of containers that have been packaged into the solution, click on the More Details tab, and that will allow you to see what containers exist. And then there is this configure and launch. In the previous section, we did not do any configurations at all. Here, you can actually do some amount of configuration in terms of seeing what the what's going on. Yes, it's taking a little bit to load. So here there are three different scenarios in the smart retail analytics space. You can either choose the shopper pose mood estimation example, or the shopper count duration example, or the shelf object detection example. So let me just pick the first one. You can either bring in your own sample videos, you can upload it to the DevCloud file path, or you can even pull a video through an external RTSP URL. The number of video streams are also configurable, because in an actual real world environment, let us let us take an example of a scenario, right? Let's say you have cameras that are deployed on different corners of your retail workspace, right? Each of these cameras is actually gathering raw data, and you are trying to analyze that raw data in some form. In some cases, depending on your application, you could have just one camera deployed, you could have two, or you could have multiple streams coming in that are all giving you the data that you need to do the job. So ultimately, in a real world scenario, when you have multiple streams, you also want to make sure that you're deploying it on hardware that can take that kind of workload, right? So if you have one stream, maybe you can try it out on a Core i5, and the performance that you get is probably going to be adequate. Again, right? You have to test it out based on your example, your scenario, to actually make sure what makes the best sense for you. And that is exactly where the Intel hardware capabilities that we are exposing, offering you all these edge hardware at your disposal to test your solutions on, becomes a very valuable value proposition. So for this example, let me increase the number of streams, right? There are also different models. These are all provided as an option from the OpenVINO Open Model Zoo. So you could select which models you want. It's taking a little bit to load, but essentially this will actually give you a list of models to choose from. And ultimately you launch this on one of the Intel hardware. So let's click on launch, and let me choose from Xeon processors. Let me select the first one, and I'll run this. So like I said, right, this will be in queued state for a while. And then it will actually go from queued to waiting to actually running. So let's give this just a quick minute. Um, wait for it to deploy, because I would like to show you the output of this before I move on to a pro code scenario where I'll open up a Jupyter notebook IDE and show you how to build containers using Docker files. Are there any questions on the line while I'm waiting for this to be deployed?
Yeah, so we had one from Sachin in the chat here. I think you already answered this by way of just explaining, but is it possible to pipe live video into these examples instead of pre-recorded clips?
Yeah, so you could actually, today you need actually a pre-recorded file, right? You could bring it through any of those methodologies, the URLs that I talked about, the file system and an external RTSP URL.
Okay.
So now this is deploying, right? So let me open this up. And as you can see here, we selected 4 video streams, right? It's loading a little. It's taking a little bit of time, but essentially what you're doing is all of those different models that we had. There were 3 different models, right? It is doing a pose estimation, it's looking at the emotions, things like that, and then it'll provide you with an inference result. And ultimately what you're also seeing here is what is this per stream FPS that you're getting? What is the total FPS that you're getting? Things like that, right? This is just data that will vary depending on the different hardware that you choose. But this is a good way of experimenting for you to see what hardware gives you the best performance possible, right? So these are some of the options where you either run things out of the box, or you kind of evaluate this based on some amount of configurability. But now what I would like to show is it starts getting a bit more complex scenarios of what we're kind of encountering here, right? Well, I'll show you next what you could do to actually use some of the samples that are built into the smart retail analytics. So in the first example where I showed the people counter, right? It's detecting the number of people in the frame. It is detecting their pose, mood estimation, all of that. So because that sample actually uses the people counter system, I'm just going to open this up, because an organic question that most developers would have is, yes, I manipulated something. I saw what that performance actually looks like. Now I want to open up the code and see what's in there, right? So if you click on this view edit code button, what you will actually get to is this Jupyter Lab environment. You can launch a new launcher, and as you can see, you have different Python kernels. You can actually do things that you want to use the terminal for. That capability exists as well. Each of these documents, each of these files, each of these sample applications that I will launch through the marketplace, they're also very, very clearly documented, because again, like I said, most of you might be trying to learn what you can do, right? So we want that capability to be available to you. So these are extremely well documented. If you go to the README file, this will actually show you what are some of the base images that it is using. What are some of the entry scripts that this particular example is using? What are some of the parameters that you could change to ensure you run on CPU versus GPU? The different precisions that you'll need for your model. And how exactly would you build a container using the Docker files? As you can see, if you open up the Docker file folder, right, there are multiple Docker files here for different versions of the OpenVINO toolkit. And this particular example is using OpenVINO in the backend, but in the actual container space, there is no requirement for OpenVINO. You could have all of your requirements all packaged in one file, and you could test that, right? So I'm just using this sample application, and you could open up one of those Docker files, and let me do that. 2022, let me open up the most recent one. And this is exactly where all of the, the entry points, the base images, those are all set, right? You want to run it on the CPU. If you want to run it on a GPU, you can make the modifications here, either through the file, or I will also show you another place through the UI where you can make those changes. So essentially, using these Docker files, this is a command line interface. This is a IDE, a very popular IDE that most people that have been developing in the space of AI would know Jupyter Lab. You might have used it for various tasks in the past. So we will use this to actually build a container in the command line. Again, like I said, right, all the instructions that you need are very clearly documented. This set of instructions will draw quite a lot of packages from the backend, right? So in the interest of time, what I have actually done is go to the root directory of your samples, right? That's the first step, and just use builder as a tool to build the container. And I call that container people counter custom, and I'll put it in the current file, current folder, right? And then push that to the private registry. Those are steps that I have pre-run, because this will take a little bit of time. Like I said, it's pulling quite a lot of packages from the backend, right? As you can see here. And then I've also pushed it to the registry. But now when you push it to the registry, you should be able to access that from within your dashboard, right? So if we go here back to the Container Playground UI environment, you go to My Library, you go to Resources, and if you see here, the container that I created on the command line using the Docker file has now been pushed into the dev cloud registry, and it's available for me to use here. So I could also configure, right? The configure import could also be configured. If you look here, it will allow you quite a few options. And then let me go back, show you if you have to assign it to a project, and then you can run it. Assign it, create a project. Let's just say people counter. I've assigned it to a project. At this point, it should show up inside the projects tab, and you will be also able to configure this container. So there are a lot of options here that are available to configure containers. This is actually a simple example where I'm showing this one container, right? Essentially, you may want to expose ports. You may want to set an entry point for the scripts. You may want to set up the output mount point from where you want to see some of the inference results or logs. And how do you also set some of these environment variables, like the example Docker file that I showed? The device that I'm running on was set to the CPU, right? But if you wanted to actually make a change and run it on the GPU, you could use the environment variable tab here and change them. Also, you could have multiple containers. So you also will have the flexibility to tell what the order should be that these containers should run in, right? So all of those capabilities are available. So if you want to read a bit more about how to actually go about doing each of these individual configurations, from within the container playground, there is a documentation tab. If you click that, this will actually open up, where is it? It will actually open up the developer guide, and you can take a look at detailed steps of how to replicate all of the stuff that I'm showing here today, right? So now let's go back. There are a few more scenarios that I would like to cover. So there are three things that we saw, right? One is running a full stack implementation out of the box, no change. The second was the configurable solution, where there were some things that we adjusted. We adjusted the number of streams that were coming in. We showed how you can actually pull in different images or different videos, right, that you're doing your inference on. We showed how you could select different models through that example. Now, in the third example, we actually picked one of those models. We opened that up in a Jupyter Lab environment. We used the Docker file that came with that sample application, and we built a container, we pushed it to the private registry, and we are able to run from within the UI environment on any of the Intel hardware. Those are the three scenarios that we have covered today. But there are additional examples, right? So now I told you earlier that there was a possibility if you had containers already, you may have developed containers already. And if you want to pull any of those from an external registry where you may have hosted them, how do you do that? So let's go to my library and resources, click on import resources. You have container from registry. If you select that option, this will give you an option to create a project. Let's just say I want to import Nginx, right? I'll create a project, and now I have the option to import it from registry. So let's say Docker, let me just pull it from Docker. Let me see if I remember. Stable, well, I think this is the tag. Okay, and then I say, give a name for the container and import.
For those unaware, Nginx is one of the more popular HTTP servers. It's sort of taken a big bite out of the dominance the dominance of Apache over the last decade or so.
Thank you so much for adding that point, Phil. Good point. Right, so it was successful. I remembered the tag correctly. So now you have the option to configure that particular container, right? So let me just, leave this as is. And again, you save the configuration, and at that point, you are able to launch this on any Intel hardware of your choice, right? So what the launching process looks like is similar for all the examples. So I don't want to repeat the same set of steps. But essentially, if you wanted to pull in a container from, let us say, AWS, or you want to pull something from Quay or Docker, as I showed. If you check the documentation, all of the supported external registries are called out. So please take a look at that, and you should be able to pull containers from any of those registries. So now let me go to the next scenario where I would like to pull in a Helm chart and show you some of the capabilities. Because the example that I am going to be using will use some of these Helm charts that I've already used through a different example. Let me delete them, and then I should be able to re-import them. Okay, unassign, and delete. Okay, so now if I actually go back to my library, resources, import, let's go to the Helm chart example. Again, I'm just only showing pre-built samples, right? You could bring in your own Helm chart and use that also. So let's use the same example here. This is just the repo and test. And I can pick from one of the examples here and say submit. What this is actually doing is when you pull in a Helm chart, there are some vulnerability checks that we are doing on the container playground side as well. So when you see the differences here, the original Helm chart, there are some modifications that are made to actually pull it into the file system. What the changes are, that is very clearly shown to you. And then you create a project, assign it to it, save the configuration, and at this point, you're again able to launch this on any of the Intel hardware, similar to some of the previous examples, right? So this is another scenario, very powerful, because Helm, as I mentioned, is a graduated CNCF project. Most of you may have used Helm charts, which are YAML files essentially in one form or the other. So this is another option that I would really encourage all of you to check out as well. Now let's go back and see some of the other samples, right? So one thing that I want to also show you is importing from source code, right? So if you actually have an example that you want to kind of pull in from the source code repository and then build a container out of, you also have the ability to do that. So if I go to the developer guide, where was the developer guide? I just opened it. Yes. So if you go here, you will have some of the examples that will show you how to do it. So let me open up one of them. Again, right? If you have package dependencies, there is a way of doing that. If you don't have any package dependencies, there is a way of pulling that source code and building containers out of that as well. So for the purposes of just today's example, as you can see here, there are a lot of languages that are supported too. You have Python, you have Java, Node.js, PHP, right? So just for the purpose of an example today, let's just use one of these examples. Oops. Go back. With base image, get repo URL. I'll just copy paste that. Repo name, I'm just using a CPP example. And let's say this is the sample that I want to use. Let's say verify.
And so what pre-flight checks is it doing security-wise when it's doing this URL check? Does it, scan it for like vulnerabilities or whatnot beforehand?
Yeah, exactly. Because there are few things that we have to keep in mind when we are actually building containers, right? One is, as a developer of a container, it is a best practice to run some of the security checks ahead of time, right? Catch some of those vulnerabilities ahead of time. On the container playground, when we are trying to import, it's also one thing I would like to call out. This is also a multi-tenant system, right? We are actually allowing you to test your container on the cluster. We're not really providing any kind of cluster management capabilities because there are some amount of guardrails that have been put in place. We also want to make sure that when we import a container, the containers are safe. We provide enough encryption capabilities to keep your container secure, also the environment secure. So there are quite a lot of security vulnerability checks that happen behind the scenes.
Yeah, that makes a lot of sense. There's a lot that can go wrong here. There's a lot of
Mm-hmm.
potential for harm, and to mitigate that, the only thing forward is to run these checks.
Yep, absolutely. So as you can see here, right? So there are multiple options. You can select the pre-built script. You can actually set the arguments, the command line arguments, the entry points. Once you handle all of that, you can also set the output mount point. And once you do all of these steps, it will again allow you to launch the container on any of the Intel hardware. And the reason why I'm actually showing this is it's giving a snapshot of all of the type of source code that you can bring in and build your containers using. So with base image, we saw that if you don't have any dependencies, there is a way of doing that too, right? So those are some of the demo capabilities that I really wanted to showcase. Um,
Awesome.
let me actually show one other thing. So when we actually go to the file system, right? I think I mentioned bring your own container. I also mentioned bring your own source. Those are the examples that I showed so far. But the one thing that I called out very early in the presentation was the capability to actually bring your own models, bring your own data, right? So let us assume you have your models uploaded on the AWS S3 bucket. There is a connector, a cloud connector capability, and you access that using my library file system. And you click on connect, you should be, it will ask you for your access and the secret key. Then you'll be able to pull your entire data set models from your AWS S3 bucket into the dev cloud file system. And then you should be able to build containers out of that as well. So that is the bring your own data pathway.
Ah, makes sense. Yeah, so much can be done here. The configurability is really sort of mind blowing. I can see why. I can see how much work has gone into building this system out. There's just so many little things that have to be done here. So, congratulations to the whole Dev Cloud team
Thank
for
you, Phil.
getting this into the state. And then, yeah, and thank you so much for the great presentation. We've got a few questions here. First, I think it's time we'll do our giveaway. If you'd unshare your screen for me, please.
Absolutely.
Awesome. Yes. So if this is your first time joining us, or you just need a little reminder, one of the things we do every single week here on OpenCV Weekly is give away something to you in the audience. This week, you'll have your chance to win a free copy of the Mastering AI Art Generation course, which is currently on Kickstarter. You can check it out at opencv.org/Kickstarter. I'm going to be asking a trivia question based on the presentation by our illustrious guest. The first person to answer that question correctly in the Zoom chat window will win the AI course. If you have won in the last few months, please do not answer and give someone else a chance to win. This one is going to be a little two-parter. We saw there are a couple of ways to use Intel Dev Cloud for the edge here. There is bare metal development and containerized development. The bare metal development uses a specific IDE. Which IDE is that? The containerized development has a certain technology powered by Red Hat. What is the name of that technology? These are two answers. You must answer both in the same chat message to win. Okay, we got some people getting one of them, but not both yet. I think I'm going to have to give it to Divya Pavagada, who the answer we were looking for was Jupyter or Jupyter Lab and Red Hat OpenShift. Those were our two answers. Congratulations, Divya. Please send one
Congratulations,
email.
Divya.
Yes, please send one email to phil@opencv.org, and we will make sure that you get your copy of the course when that goes live on May 1st. For those of you who didn't win, good news. You can go to opencv.org/Kickstarter and pay just $29 for this awesome course, our most affordable course ever. It will launch in the beginning of May and should only take maybe a weekend or two for you to become an AI art generating master. I've got a few questions here from the audience. First, I'd like to Art Chong, who would like to know, a lot of their projects use PyTorch. What is the current support for GPUs, APUs, DPUs within these edge containers, Meghna?
Yeah, so I think one thing that I talked about earlier was the access to the edge hardware, right? There are more and more new hardware that we are getting into the system on a very regular cadence, and we hope to have discrete GPUs accessible for edge nodes real soon. So I would really encourage all of you to watch that hardware page, and anything that we will upload there should actually tell you when that particular hardware becomes available. And also, I think the first part of the question was also about PyTorch, right? So there are samples if you go into the dev cloud for the edge environment, the container playground environment, you will actually see that there are quite a lot of PyTorch samples there as well. So there is support for that. So I would really encourage all of you to check that out as well.
Awesome. Another question here from Ralph, who would like to know, is it possible to use these containers on the Movidius compute stick?
So today, I believe we have VPU support on the bare metal side of the development. There are HDDL boxes that actually provide about 8 VPUs supported. But let me go back and see if there are similar capabilities on the container playground side. I'll have to check, but it's definitely available on the bare metal side today.
Great. We've also got another question about capabilities. Are there any models available on the marketplace for analyzing voice data, transcoding or transcribing or modifying or whatnot?
Today, I believe we do not in the samples, but this is something I can actually take as a request to our engineering team if there is an interest, and see if we can actually incorporate a new sample that might showcase some of those key capabilities.
Yeah, that would
Today, I
definitely
think
be
we
interesting for me.
predominantly focus on some of the vision models.
Which makes sense because that's the primary use cases these days. We do see a lot more use of audio for, generating music, classifying spoken words, things like that. So I think it'd be a pretty good addition, and definitely Danilo here would agree with me. Steve Simpson would like to know, is there support for the Myriad X, such as in the Oak D or Oak One cameras?
So that's similar to the first question, right? The Myriad is the VPU processor. So let me take that question and revert back with an answer. I know that it is available on the bare metal side, but on the container playground side, I doubt it is available today. But I'll have to cross-check.
Yeah. All right. Thank you for that. We'll post an update or something
Yes.
on socials when that we know for sure. Let's see. Those are most of the questions here. I think I see. Yeah. Steve Simpson is curious about, is there a premium business model? Is there something for enterprise as part of the dev cloud? Because you've talked a lot about how free most of this is, but
yeah, so there is actually an opportunity for users who may be interested to get in touch with our sales team. I can drop that chat. I can drop that URL from the dev cloud on the chat window as well, Phil. So for enterprises to engage with us, it would be wonderful if you can get in touch with us, and we can talk to you more about what it is that your requirements are and take it from there.
great. Yeah, sounds like something that Steve there may do. Yeah, we're just past 10 o'clock here. I think we can go ahead and call it
So
an
Phil, I think there
episode.
is one last question that came in
Yeah.
that Pankaja is asking about where they need to go to actually create an account.
Yes.
So it's devcloud.intel.com dev/edge. That is, let me paste it in the chat window.
I just did. Yes. So yeah, you can find that devcloud.intel.com/edge.
Yes,
I just
perfect.
posted it in the chat. We'll
Thank
also
you so
make
much,
sure that
Phil.
it's in the show notes here.
Yeah. And if you have any trouble, creating an account, there is a very strong forum support for the DevCloud for the Edge. If you have any issues or if you encounter any issues through the process, please post a message there and somebody will get to you as quickly as possible and help you get sorted out. The idea here is this is a development sandbox, right? We really want to make sure that we provide you with the capabilities that are relevant. We provide you with the tools that are necessary to make your job easier and take you further along your journey. So that's kind of what we hope to strive for. If there are areas where you believe you need additional capabilities, please also post them in the forum so we are able to capture that and figure out what we can do to actually incorporate some of those features.
Yeah, that's a great point. A lot of the times with these systems, they don't really know that you want something unless you tell them. So go ahead and hop on those forums. You'll be able to find a link from that sign up page to those forums as well.
And everybody's journey is different, right? You
Mm-hmm.
may be doing different, you may be at different aspects of the journey. You may be doing different things, different types of application. Like somebody pointed out, there's a voice application that you want to build, right? We would like to know what it is that, as use cases that you're trying to do, so we can provide more relevant examples for you to get started with.
Yeah, absolutely. Thanks so much for joining us this week, Meghna. Hopefully we'll have you back
Absolutely.
again in the future to
Oh, I
learn
would love to.
we'll learn a little bit more
I'd love
about DevCloud in the future from you. Stay tuned for that. Same bat time, same bat channel, 9 a.m. Thursday Pacific time. Before we say goodbye this week, I would like to give a hearty happy trails to Kenosha, Wisconsin's own Burt I. Gordon, master of low-budget cinema, known for such films as Empire of the Ants, Village of the Giants, The Amazing Colossal Man. He's done a bunch of episodes of one of my favorite shows, Mystery Science Theater. Passed away at the ripe old age of 100 years old. Happy trails, Burt. I hope you're making schlocky movies somewhere nice. Take care of yourselves out there, folks. Take care of somebody else if you can. We will see you next week. Adios. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.